Our goal today is to thoroughly discuss the topic of simultaneous equation modeling, particularly examining scenarios where we encounter several distinct equations that must be estimated all at once. So in this discussion, we're going to focus on addressing two primary concerns, specifically the problem of endogeneity and also the issue of cross-correlation of errors that exist across these various equations. For instance, let's take a look at a particular study, which was authored by Catherine and Paul and subsequently published in the esteemed Journal of Empirical Finance, where they meticulously analyzed the intricate connection between a company's cash flow and its financial leverage. Consequently, what we observe here are three distinct equations.
We are modeling the cash flow, taking into account its various time lags, the current level of leverage, and also the historical lags of that leverage.
And finally, our assessment is based on risk, specifically considering the current level of risk and also any lagged risk. We then apply this same approach to leverage using the identical variables, cash flow, the actual leverage, and the associated risk.
And when modeling risk, we are using cash flow, leverage, and risk itself. As we can observe here, the variable x is effectively appearing as y, and this same relationship holds true for both leverage and risk. Therefore, what we are dealing with here are clearly endogenous variables. So the fundamental concept we're discussing here is that it's essential for us to accurately estimate these particular equations, and crucially, this must be done in a simultaneous manner. Now, when we consider the intricate connection or the relationship that exists between a company's cash flow and its financial leverage, it's important to understand that this relationship generally adheres to two primary theoretical frameworks. The first point, or perhaps we could call it the first principle, suggests that there's a clear pecking order preference for utilizing internal cash flow rather than relying on external debt or leverage. Consequently, businesses would naturally choose to fund their operations and investments primarily through their own generated cash. And if there isn't sufficient operating cash flow, firms will then need to rely more heavily on financial leverage. This dynamic will create a clear negative relationship between their cash flow and their use of leverage within that very same period. Consequently, the immediate contemporaneous relationship observed between a company's cash flow and its overall leverage is therefore consistently expected to be negative. However, if we carefully consider the dynamic relationship between these elements across various and distinct time periods, then it's possible we could observe a significant signaling impact. This is where firms might strategically choose to take on more financial leverage, specifically to signal to the market that they possess higher current cash reserves and anticipate even higher future cash flow generation. So these firms would take on more debt or leverage as a strategic move to clearly signal their inherent ability to generate significantly higher cash flow, thereby demonstrating their capacity to comfortably meet their financial obligations and repay their outstanding debt.
Now, to submit this information using the Finances Edge Gate website, I will be employing the annual method, despite the fact that the original paper utilized a quarterly approach. I'm choosing a single frequency because X and Y are observed to share the exact same frequency. I'm going to pick the whole sample first of all, and then I'm going to pick the X variables specifically. Now, in this situation, because the X values are presenting themselves as a Y value, we must proceed to select every single X variable that is directly related to this context. Our primary variable for consideration here is cash flow. Therefore, I need to locate an appropriate correspondent or an equivalent term that is similar to cash flow. So for our initial consideration, I'd like to select cash flow relative to price. Then the second important variable we will be examining is going to be leverage. And here we have a proxy for debt or leverage, and the last one is risk. And I'm going to be using idiosyncratic return volatility as a specific measure of risk. Now, regarding the Y variable, we won't be focusing extensively on its selection at this point, primarily because each one functions as a Y variable within a simultaneous equation system. However, we should select a Y variable that possesses a sufficient number of observations which must be greater than the minimum observation count for the X variable we have chosen. For example, if I were to select the option for age, then I would scroll down just to make absolutely sure that everything is correct. The specific Y value that I chose, which was a random selection, has a significantly higher number of observations compared to the minimum X value. The primary reason for this is my need to ensure that the effective working sample size is not unduly reduced simply because of the specific Y variable we've chosen to employ. And this particular choice isn't actually of great significance in this specific scenario, given that these variables could interchangeably serve as both the independent X and dependent Y variables. So by selecting age, we have 86,000 observations. This is well above the minimum requirement. It means we're not reducing our effective working sample size. Therefore, we can confidently proceed with this selection. Now, the first crucial step we need to address here is the development of an appropriate instrument for these particular endogenous variables. Since each and every one of them is, by definition, endogenous, it is therefore essential that we carefully select a suitable proxy for each. And as for the instrument, I'm going to be using the industry level
So I'm going to create an industrial level aggregate for every single variable.
The reason is that the industrial level variable would be a proxy for the firm level variable because the firm operates inside the industry. So that would be a good instrument for our specific case.
So the first step is for me to select the appropriate industry definition. For this, I've decided to use the widely recognized standard industrial classification system. Naturally, I'll choose to work with the median, primarily because it's much less susceptible to being skewed by extreme outliers, and then I will proceed to construct these essential industry level variables.
Moving on, the next step involves addressing the lags. This is because within the scope of this particular study, we are employing 4 quarterly lags, and in certain instances, we're utilizing 8 quarterly lags, which is determined by M1 and M2. And since we're using annual, say I'm just going to use 2 lags, so I'm going to pick X, which again would be treated as a Y in the other equation. And I'm going to select a couple of specific time delays, and then I will combine them.
We're very close to finishing up, but at this crucial stage, we absolutely need to handle these unusual data points, the outliers. So I will now proceed to apply the unsensorization technique.
And you need to carefully choose the variables. I'm referring to all of the specific variables that we have meticulously selected and painstakingly created for this particular analysis. And we'll make our surmise at the 1% significance level, and then we'll proceed to create them. All right, we're completely prepared now. We've gathered every single variable pertinent to this specific situation. What we need to do is to scroll down to the advanced regression analysis section. Then we must select the Y variable, even though we won't actually be using it, but we are required to select Y in order to properly initiate this section. Now, regarding the regressors, it is essential that we carefully choose each variable that demonstrates a singular upward movement or increase. And then following that step, we carefully proceed to select the appropriate simultaneous equations for our analysis. I could have 2 or 3 of these, or perhaps even more than that, but in our specific case right now, we are working with 3 equations, so we're going to go ahead and set that number to 3. Before we proceed, it's crucial that we first establish a clear definition for what we refer to as instruments in this context. To achieve this, we will then proceed to employ the aggregate variables found at the industry level serving as our primary instruments. So in this specific situation, I'm going to pick our yet to be identified industry level variables. Since the firm is part of the industry, then these industry level variables will certainly have an impact on the firm. And we cannot reasonably anticipate that firm level variables here could significantly influence the broader industry level, primarily because any given industry encompasses a multitude of individual firms. So the cause and effect relationship must clearly proceed from the industry to the firm and not the other way around. So this approach will provide us with the predicted values for the endogenous variable, and ideally it should effectively resolve the endogeneity problem we've identified. Now for our first equation, we will carefully select the cash flow.
Consequently, the endogenous variables within our analytical framework will comprise the remaining 2 distinct and crucial elements.
So the crucial factors we're examining are the inherent risk and the market leverage. Consequently, the Y variable, as a default, is inherently endogenous, naturally sidepause. It's essentially determined by other variables within the system. Furthermore, on the right-hand side of our equation, we find endogenous variables. The primary reason for this is the leverage, specifically the current level of both leverage and risk, which are inherently endogenous. This is due to their appearance as a dependent, or Y, variable in both the second and third equations. So, by definition, they are endogenous. However, we can also choose to include exogenous regressors in our models, such as factors like firm size, asset tangibility, and perhaps even profitability. But for this discussion, we're going to keep the case quite simple and focus primarily on these 3 variables, though we can certainly add more if we need to. So for the exogenous regressor, in this specific instance, we're going to proceed by selecting the lagged version of these particular variables. And as I've mentioned before, we also have the option to select other relevant variables. For example, something like size. Consequently, we consider the lagged variables, which are essentially past observations, to be exogenous. This is primarily because we are making the assumption that these variables are not correlated with the R term, which represents the error or residual component in our model.
So any variable that does not correlate with the R term can be considered exogenous, and we will make this assumption.
So in this particular step, I will be selecting the lagged values of both leverage and also the lagged values of risk. That completes our work on the first equation. Now, moving on to the second equation, our primary objective is to model the leverage itself.
We're going to select the unsupervised leverage as our primary focus. The endogenous variables in this context would specifically bear the other two key factors, the unsupervised risk and the unsupervised cash flow. The exogenous variable, on the other hand, would be the lagged
of these critical variables. Consequently, our next step involves carefully selecting every single lagged X variable that we have already identified and chosen from the preceding analysis. These are the key indicators we're focusing on, specifically the inherent risk, the financial leverage, and the crucial operational cash flow.
It appears that in this specific situation, I unfortunately failed to properly select the correct lag for our cash flow analysis. I must now choose the option that is considered the standard, the one that won't cause any unexpected issues.
Now, finally, we have the third equation modeling risk. So I'm going to pick the unsurprised variable for our next step.
This refers to the unique and specific volatility of an asset, which is commonly used as a direct measure of its inherent risk.
The endogenous variables in our analysis will encompass the two additional measurements taken during the current reporting period. Specifically, these are the market leverage ratio and the cash flow to price ratio. As for the exogenous variables, these will consist of all the lagged values of these three specific variables that we have just discussed.
First, we examine the cash flow projections, then we assess the associated financial risk, and finally, we average the expected outcomes.
Naturally, it's essential that we include every year within our sample data, which means this setting must remain activated. Here you can carefully check and confirm if the identification assumptions are indeed correct, meaning that we have a sufficiently large number of appropriate instruments available for all of the endogenous right-hand side variables. And this is indeed the situation. If we have fewer instruments at our disposal, the entire system would be considered under-identified, and we would then need to thoroughly re-examine and adjust. Here, we'll present a summary of the selections we've made, as discussed earlier. This brings us to the first crucial stage of our analysis, which is the instrumentation. In this phase, we carefully instrumented the endogenous variable by employing the specific instrumented variables. So we create an expected value so we can solve for the endogeneity issue.
The main coefficient will appear right here, as you can see.
And the other key idea, the simultaneous equation approach, is also designed to account for the various errors that can occur across different equations. So for instance, we might have an error here, another error here, and yet another error here. Crucially, we are not treating these individual errors as if they were completely independent. We are making the explicit assumption that a cross-correlation is present between these observed errors. We then take this into careful consideration when we proceed to estimate the coefficients. This methodology enables us to obtain more statistically efficient estimates for the coefficients. So, the cross-correlation of the errors will be accounted for within the simultaneous equation, specifically in this case the 3SLS.
Let's go back to this section, just checking the coefficients.
We observe a clear negative correlation between a company's financial leverage and its available cash flow, which strongly supports the well-known peaking order theory. This essentially means that if a business takes on more debt, it's typically because they are experiencing a period of reduced cash generation. That truly creates very negative relationships, specifically within that contemporaneous time frame, in that exact same period. You can also check the other relationship, like risk. And that is positive, meaning that maybe with the higher cash flow, we have more risk. We can also examine its relationship to the other equations we've discussed. This is a second equation, and in this particular case, we observe that we have significant leverage, and the resulting cash flow here is actually negative. Again, this strongly supports the peak in order theory that we've been discussing. When a company possesses a greater amount of available cash flow, its requirement to secure external financing or debt, known as leverage, to fund its strategic investments or any operational endeavors it plans to undertake, significantly diminishes. And in this particular context, we are presenting all of the estimated coefficients derived from the three-stage least squares regression model.
Now, at this particular stage of our analysis, we will proceed to apply as our initial step the iterative GLS method, which is formerly known as generalized least squares.
This means we'll need to perform a significant number of iterations in order to obtain a truly stable and reliable estimate for the variance, covariance, and the overall error term.
However, there are instances where that iterative process might not be successful, yet we can still manage to determine the cross correlation of the residual error term.
So even if that particular calculation isn't performed, we still revert to the standard approach, which is known as SUR, or seemingly unrelated regression. We've already had a completely separate video where we discussed the SUR. However, we're still dealing with the situation if the iteration process doesn't yield results. The iterative process is solely intended to refine the variance, the covariance, and the associated error term. But even if that particular approach ultimately fails to achieve its objective, we are now falling back to the SUR style of estimation, which means we must still carefully account for the errors cross-correlation that exists across all of these various equations. So that brings us to the end of our overview of the 3SLS method. Thank you very much for taking the time to watch this presentation.